the statistic. And before that, please sign your attendance so that we can add into your carry mark for final exam. The topic we will be discussing today is about the sampling distribution of mean according to everyone's creativity. So first of all, I need you all to distribute yourself among your friends, and you need to discuss about 4 important things for this discussion. The first one is the concept of sampling distribution of mean. The second one is about the properties of sampling distribution of mean. The third one is central limit theorem. And for the last point is solution based on some related numerical example. So I need you guys to sit in your group and discuss, and after 10 minutes I will need everyone to present in front. Okay. Now we need to end the discussion, your group discussion, because we have to call everyone to present now. For the first part is concept sampling distribution of mean. Let us call the first group to present about their points.
Okay,
Miss.
Okay, Miss.
Good evening, everyone. Today we are going to present about sampling distribution of mean. I am Norija Vidya Abdul, and my friend
I am Omishan.
Do you know that about the sampling distribution of mean? Sampling distribution of the mean is a probability distribution consisting of all possible sample mean of a given sample size selected from a population. The second.
The distribution of all possible sample means if you select all possible samples of a given size.
Sampling distribution of the mean is unbiased because the mean of the possible sample mean is equal to the population mean.
So, that's all from us.
Good evening, Miss. Okay, now we are going to present to you about properties of sampling distribution of mean. I am Anis.
I'm Shamina. Okay, the first properties is mean of the sampling distribution is equal to the mean of population, and the second one is the standard error, where the standard deviation of sampling distribution is equal to the standard deviation of population divided by the square root of size of sample. SPM is a random variable, so it has a probability distribution, and it is also used to estimate the parameter of the population distribution and making inferences about overall population.
Okay, now how are we going to know whether the standard deviation is small or large? Okay, first one, if the sample mean were very close to the population mean, the standard error will be small. The second one is if the sample mean were very far away from the population mean, the standard error will be large. Okay. Second one is the more properties of the more properties of sampling distribution of mean is there is no outliers or other important deviations, and the center of the distribution is very close to the true population mean, and it is determined by the sampling design and the size of sample, so it will affect the standard error or the sampling distribution mean. And then the last one is the larger the sample will give the smaller spread, so the value will be so small. Okay, that's all from us. Thank you.
Good evening, Miss. My name is Vanessa,
My name is Desmond Su.
and we will present about central limit theorem. As the sample size gets large enough, The sampling distribution of the mean is approximately normally distributed, no matter what the shape of population distribution are. And how large is large enough? When the sample size is at least 30, the sampling distribution of the mean is approximately normal.
There are three examples of central limit theorem. The first one is to find the probability that the mean is greater than a certain number. Here is an example. Given a normal distribution with mu equal to 101 and sigma equal to 15, if you select a sample of n equal to 9, what is the probability that x bar is above 101.8? Now there is a few steps to solve this problem. The first step is to identify the parts of the problem. According to the problem, it is given that the mean equals to 101, the standard deviation is 15, the sample size is 9, and px bar greater than 101.8. So the second step is, by using this formula, we can find the z-score. So this is how we solve it. We put the data in the formula. It will become like this: 101.8 minus 101 over 15 divided by square root 9, and we will get the answer 0.16. Now the third step is to draw a bell curve graph. A bell curve graph looks like this, and we label the center with 0, and this is the z-score we found just now, and this is the part that we want to find, z greater than 0.16. Now the fourth step is look up the z-score you calculated in the second step in the z-table. Now the z-table doesn't shows the shaded area, but it shows this area, so we have to use 1 minus this part to get the shaded area. So this is the z-score, and this is the 0.16. So we use 1 minus this 0.5636, and we will get 0.4364. And the last step is convert the decimal into a percentage. So the percentage will be 43.64%. You just take this 0.4364 times 100, it will become this percentage.
The second central limit theorem is to find the probability that the mean is lesser than certain number. According to the question, the mean is 42.5, standard deviation is 13.6, sample size is 25. Then we are using step 2, a formula to find the z-score. We put the number which we get from the question in the formula and sum it out. We will get the answer negative 0.92. And using this answer, we will referring the z table, we will get an answer which is 0.1788. Step 3. Draw a bell curve graph. The shaded area in the bell curve graph here represent to the probability which S bar is less than 40 is 0.1788. Then step 4. Convert the decimal to the percentage, which we are using 0.1788. Convert it to the percentage. The answer is 17.88%. The third central limit theorem between is the probability that the mean is a certain set of number either side of the mean. According to the question, where we get the mean with 12 pounds, standard deviation is 8 pounds, and sample size n equal to 4. Moving to step 2, using the formula to find the z-score. Using this formula, we put all the number inside the formula and calculate it out. We'll get the number 3.25. Then we referring to the z table, we'll get the answer, which is 49.94%. Then we calculate the next one, which the probability x is less than 8. We put all the number inside the formula and calculate it out, we'll get the negative one. But we need to ignore this negative sign. Just look out for the 1 in Z table and we will get 34.3%. That's because both sides of the distribution are symmetrical. Then we move into step 3, draw a bell curve. The shaded area in this part represent to 49.94% and the shaded area in this part represent the probability S is larger than 8, which is 34.3%. Then we move into step 4, sum all the number out. Then we'll get 84.07%. This answer represents to the average weight of the dog, which is greater than 8 pounds and less than 25 pounds.
Good evening, Miss. My name is Camelia.
And I'm Pamela Angel.
This is for the discussion. The question is solution based on the sum related numerical. For example for the solution, suppose a simple random sample of size n is 36 is obtained from a population with mean 75 and the standard deviation is 12. In order to find a standard error, this is the formula. Standard deviation divided by square root of sample size. So the standard deviation 12. The sample size is 36. So the answer is 2. That's all. Thank you. For the question 1, what is Px more than 77.1? For the illustration of the graph, this is mean, as you can see. Okay, this is mean 75, and this is the x 77.1. So to find this we use this formula. This is for z-score, the formula is x minus by mean over by standard error. Why standard error? Because we use a sample distribution of mean. So 1 minus by z-score, and then this value we find it in the z-score. Okay, so the answer is 0.14969.
Similar to the previous one. The question is, what is Px less equal to 70.8? So this is the illustration for the question. 75 is mean, and to find out this one, you need to calculate the z-score. And then to find this one is 70.8 minus 75 divided by 2, and then you will find negative 2.1. To find out this one is you need to look from the z-score table.